guys, today we're on 10.4 day 1, finding the GCF. And you might remember this from like middle school. GCF stands for greatest common factor. So we're going to be doing it with numbers and variables. So with only numbers, let's say your goal is to find the GCF between the numbers 12 and 16. Now what that means is find the biggest number that you can divide both 12 and 16 by evenly. Now some of you are going to be able to do this in your head, but if you'd like, I'm going to show you a way to make sure that you always get it right if you're not so fast with this in your head. So what you do is write down all the factors of 12. So 12 could be 1 times 12. 12 could also be 2 times 6. 12 could also be 3 times 4. So you just write all the factors of 12. And then write all the factors of the next number. So what are all the ways to multiply to get 16? 16 could be 1 times 16. 16 could also be 2 times 8 or 4 times 4. I think that's it. Yeah. And then what you want to do is see, do they have any in common? And it's got to be the biggest one. What's the biggest number that 12 and 16 both divide by evenly? So they both have a 1, they both have a 2, and they both have a 4. You want the greatest common factor, so it's 4. Okay, that's the long way. Some of you could probably do this in your head and just come up with that the answer is 4. All right, let's do a couple more. So 6 and 12. I'm going to do it the long way first. 6 is really either 1 times 6 or 3 times 2. And then we just did 12. It's either 1 times 12 or 2 times 6 or 3 times 4. Okay, what is the biggest number that's in both rows here? So they both have a 1, they both have a 2, and they both have a 3. It's the biggest one that they both have, so the answer is 3. Okay. Now, shortcut is to kind of do it in your head. What do 9 and 21 both divide by? What's the biggest number that they both divide by? And maybe you guys can just do in your head that it's 3. But if you need the time to write this out, do it. Now, what if there's 3 numbers? It's the biggest number that all 3 of them divide by. So let me do this one out here. So 6 could be 1 times 6 or 2 times 3. 15 could be 1 times 15 or 5 times 3. And then 9 is either 1 times 9 or 3 times 3. I think that's it. Okay, what's the biggest number that all 3 of those have in common? They all have a 1, and they all have a 3, so it's also 3. Okay, and the next one I'm going to do in my head, but if you want to write it out, go for it. 10, 20, and 30. The biggest number that divides into all of them is actually 10. And you would see that if you wrote it out. Okay, now finding the GCF with variables. This is actually a lot easier. Okay, so let's say you want the GCF between k squared and k5. So k squared, we're going to do the same thing, is just k times k. And k to the 5th is just k times k times k times k times k, 5 times. what's the most amount of k's that they both have? Okay, that's the question. And it ends up being 2 because this one has 2 and this one has 2. So it's the most amount that they both have. So the GCF ends up just being k squared. Now there's a trick. There's a shortcut to this one. When you're doing variables, the shortcut is if you look at all the powers, it's always the smallest one. Okay, that's the shortcut. So number 1, let's do it the long way and the short way. So the long way, x to the 4th is just x times itself 4 times. And x to the 6th is just x times itself 6 times. Now GCF is what is the most amount that they both have? Well, this one has 4 and this one has 4. So the GCF is x to the 4th. It can't be any more than that because this one doesn't have any more. But look, the shortcut would have said, look at the powers and it's always the smaller one. That's why that's the answer. Now I'm going to breeze through the rest using the shortcut. If there's a 2 and a 3, then the GCF is always the smaller one. If there's a 3, a 6, and a 4, it's always the smallest one. And if it's a 3, a 1, and a 2, it's always the smallest one. Okay, so that's how you find the GCF of variables. All right, flip it over. Now we're going to combine the two, finding the GCF between numbers and variables. All right, let's do it. So first we're going to do the number, 6 and 8. What is the GCF of 6 and 8? And if you need to write it out, go for it. I can tell just by looking at it, 6 and 8, the GCF is going to be 2. It's the biggest number that divides into both evenly. And then we do the power. If it's y squared and y to the 3rd, remember it's always the smaller one, so y squared. That is the GCF. 2y squared. All right, let's try some more. So number 1 here, what is the GCF of 2 and 4? What's the biggest number that they both divide by evenly? It ends up being 2. And then for the variables, it's the smaller power, P2 and P7, so it's P2. All right, the rest, guys, I would pause and try it yourself, but I'm just going to run through them real quick here. So out of 15 and 20, the GCF is 5. It's the biggest number that they both divide by evenly. And then for the power, this one's 1 and this one's 5, so it's always the smaller one. And you don't have to write a 1 if you don't want. All right, number 3. Out of 9 and 9, the greatest common factor of 9 and 9 is actually 9. And then it's going to be the smallest power. Out of 6 and 3, the smaller is the 3. And now a triple. Okay, out of 10, 5, and 15, what is the biggest number that they all divide by? And it ends up being 5. And then the smallest power, out of 8, 4, and a secret 1, it ends up being the secret 1. Okay, nice job, guys. That was a long one. That's finding the GCF, greatest common factor.